I'm recording. Yes, I am. Hi, Jenny. How are you? Let's go with your question. Feel like an academy because I doesn't matter. All right, let's go here. Your question is right here. This one. All right, let me go back to OneNote. OneNote is right here. All right. Go. Just a second. I'm arranging everything so I can explain it properly to you. All right. This is the question. It's there. Perfect. So put it a little bit bigger so we can see it better. All right. So let's start with the basics. So we know that our function. What's going on? All right, we know that our function f of x is equal to x cubed. All right. Need a second. I don't know why the pen is like that. Draw. Working all morning. Why not? Give me just a sec. Doesn't matter. Get to the point. Right. So we know that the function f of x is equal to x cubed. All right, which is this one right here. Now the function is x cubed. Also, let's call this data. Also, we know that the limit of this function when x approaches 2 is equal to 8. So we know the limit is 8. Yep, all right. Also, we know that a, so if we know the normal, not the normal, but the, not undefined, the abstract form of presenting a limit, it's x that's approaching a. In this case, a is equal to 2. All right, we also need to assume that delta is less than 1, and that will be it, right? So myself with this part right here, and we need to find delta. All right, that I think we are good. So the first thing that we need to look, just a second, I need to go down. First thing we know is that the distance from f of x to our limit, so f of x plus the limit, so f of x plus the limit L must be in the range of delta. But how do you express this? You express it in this way: f of x minus L, so the function x cubed minus the limit, it's going to be less than epsilon. Let's put procedure here. All right. The other piece of information that we have is that x minus a, which is the what we are approaching in the limit, it's going to be less than delta. All right. First thing, let's plug things in. So the function is x cubed. The limit is, if I recall correctly, is 8. And the epsilon is equal to, I forgot to place that here. Epsilon is going to be equal to 0.1. All right. 0.1. Also, we know that x minus 8 portion here should be 2. Right. So the first thing that they do is the following. So they start looking at an expression times x minus 2 will give us x to the cube minus 8. So what I have done in order to look that consistently is the following. What I have done is that I start by this. So I create an expression p times over this part right here, which is what is less than delta. So x minus 2. It's going to be equal to this expression right here. Why we're doing that? We're doing that because, as Professor Bellamino told us earlier, we need to basically convert this expression in a manner that looks exactly like delta. That way we can know what delta is. All right, so we know that p times x minus 2 is going to be equal to x to the cube minus 8. Also, we know that p, therefore we know that p is going to be equal to x squared minus 8 divided by x minus 2. All right, now we need to go for long division. So x minus 3 minus 8 divided by x minus 2. So the first thing that we need to do in a long division is to look for, oh, maybe the email stop. To look for a number or an object, let's call it that way, that multiplied by x, will give us x to the third. So that will be x to the second. So x to the second times x is going to give us x to the third. X to the second times minus 2 is going to give us negative 2x squared. When we are subtracting that from here, we're going to be getting 2x squared minus 8. So the next object, if you want to call it that way, that we're going to be needing in order to eliminate this right here, it's going to be x. No, 2x. Yes, 2x. Because 2x times x is going to give us 2x squared. And then 2x times minus 2, it's going to give us minus 4x. Right. So we're getting rid of this 2x squared. We're going to end it up with 4x minus 8. Yes. Now, the following step is to find an object, a number, or whatever, that it's going to give us 4x. Since we have x, we don't need that variable anymore. We need a number, so we need a 4. 4 times x is going to give us 4x, and 4 times negative 2, it's going to give us negative 8. So when we subtract that, we're going to be giving 0. So what we know now is that x cubed minus 8 divided by x minus 2 is going to give us p, which is what we're looking for. P is going to be equal to x squared plus 2x plus 4. We need to not take close attention, but we need to keep that in mind. What is equal to p, because we're going to be using it a bit. Right, let's put that over here. All right. So we have this piece of information. What this is telling us, give me 1 second, let me put it, where are you? Mouse instead. I'm gonna put it here with the data. Right. What this is telling us is that a factorization of x to the cube minus 8, it's going to be x minus 2, which is basically this expression right here, but solving for p, what we now have that is x squared plus 2x plus 4, x minus 2 times x squared plus 2x plus 4. That expression, it's going to be less than epsilon, which is 0.1. Just a second, I need to look, what time is it? All right, I have American history in a while, but I can finish. So what is the next thing that we need to keep in mind? We know that we need to assume that epsilon is less than 1. But if we know that x minus 2, epsilon, no, I'm talking about delta, I'm sorry. If we know that x minus 2, it's less than delta, and we also know that delta is less than 1, we can then say that x minus 2, it's less than 1. Therefore, we can put x minus 2 in this sandwich, where x minus 2 is going to be between minus 1 and 1, and therefore x is going to be between the x value in our function in order to get the limit equal to 8. It's going to be between 2, which is going to be between 1 plus 2 and minus 1 plus 2. Therefore, x in this case is going to be between 3 and 1. All right. Now we know the following. We know that this expression right here, its maximum value is 3. So what we can do is basically change that expression for our upper value. Why we would do that? Because in that scenario, we now have only x minus 2, which is what we have here in delta. So we have x minus 2 times our upper boundary in this expression right here. That will be x squared, but x is equal to 3. Let's let x equal to 3 for this expression. All right, so the x squared, which is 9, so 3 squared is 9. Then we have 2x, which is 6. 2 times 3 is 6. And then we have 4. Yes, 4. And this is going to be less than our epsilon, which is 0.1. Then we have that x minus 2 times 19 is going to be less than 0.1. But if we divide both sides by 19, we get that x minus 2, it's going to be less than 0.1 by 19. But as you can see, this boy right here, so this expression and this expression are the same. So now we have epsilon and delta to be the same. What we can do now is the following. Since we have this expression the same, we can conclude then that this part, so delta, it's going to be equal to epsilon, which is 0.1, divided by our p-value, which is one of the terms that we got from the factorization of f of x minus L, which is x to the third minus 8, which is 19, and 0.1 divided by 19, which is 1 over 90, which is 0.01. It's going to be our delta value. How can, if we did this correctly? Well, we know that the epsilon is basically the range in which we want our limit, our function to be. So if we know that we have our limit, that is x approaches 8 of x, which is equal to L, and we know that our limit is 8, or basically, no, that's right, much for an adjust simple thing. So basically, if we plug our x value, it's like if we plug our x value plus delta and our x value minus delta, it should give us an answer with a range between the limit and our epsilon. In this case, our x value is equal to 0.1. So 0.01, so f of x, the function is x to the third. So basically, x, which is our value, plus a, a, exactly, plus our epsilon value, the third, should give us a number close to this. If that's true, we have the answer. So true, so in this case, we have 2 plus delta 0.01 to the third should give us a number between 8 and 8.0, no, 8.1, 8 and for this. So our answer, we are using, our answer, let's call it R, our answer R should be between 8 and 8.1. So 2 plus 0.01, the third power, give us 8.102. If we only got the first decimal place, we need our equal range. So that's how they got the 19 you were asking me, and also is how I personally do this type of exercise. It took me a while to figure out how to do this because, at least for me, that the book is not intuitive. I didn't understand at the first glance what they're trying to do and why, but this basically is the whole process and how I do it. I hope it's helpful for you, and I'm gonna be sending you a link with this. Don't worry.